Hi, I'm Yilin. My project is Fuzzy-Embedded Long Short-Term Memory System, FELSTM in short, and its applications in Forex trading. The Forex market, which involves the trading of one currency for another, is the largest and most lucrative financial market in the world. Forex rates are influenced by a multitude of factors, thus the movements are very complex and volatile, rendering traditional techniques insufficient in modeling the dynamic time series. Inspired by the strong self-learning capabilities of neural networks and high interpretability of fuzzy systems, we proposed FELSTM to combine the strength of a deep LSTM network and fuzzy frameworks. The forward inference mechanism of FELSTM can be broken down into 5 steps. First, crisp input data are fed into layer 1 of the system, with each node representing a variable in the dataset. In step 2, each input feature is fuzzified in the second layer to form the antecedent node. In step 3, the membership values are fed into a deep LSTM network, and the predicted fuzzy membership values are passed out in step 4 to form the consequent layer n-1. Last but not least, defuzzification is performed in layer n to obtain the final output. For cluster learning, TrueSIC is adapted from MFIS, which mimics the human psychophysiological categorical learning process at different stages, whereas the fuzzy rules are learned by tagging the Hebbian pseudoweights to the fuzzy rule nodes in parallel to the LSTM deep structure. The Hebbian weight simulates the repeated firing activities of synaptic transmissions between neurons during a learning process. The benchmark experiment using chaotic Mackey Gloss time series shows that FELSTM is able to follow the complex patterns closely, and its accuracy is on par with the state-of-art neural fuzzy systems, and only 39 rules are used, striking a good balance between accuracy, interpretability, and efficiency. The topology of the architecture is optimized using genetic algorithm, GA in short, which follows the mechanism of evolution to find the best performing trait combination through biologically rooted processes such as selection, crossover, and mutation. The GA-optimized FELSTM has 3 hidden layers of 64 neurons each, with a ReLU activation function and a dropout rate of 15%. 12 USD-pegged Forex pairs are selected, covering markets from various geographical locations and development stages, with very different price patterns. Apart from the exchange rate, we also used option risk reversals to gauge the market sentiments for more informed Forex forecasting. The data is rebased first using a dynamically changing reference point to make sure the rules generated will be flexible and applicable in different conditions. The relative rate, velocity, and momentum of the Forex form the first 3 inputs, whereas the term structure and rolling z-score of the option risk reversal form input 4 and 5. The Forex rates are predicted using FELSTM with a lookahead period from 1 to 7 days, and the predicted Forex rates is used to compute the lookahead EMA, which is comprised of both a vanilla EMA of the historical Forex and a reversed EMA of the FELSTM lookahead predictions. The Forex prediction results show that FELSTM's lookahead forecast significantly improved the predictive accuracy for almost all Forex pairs by 41% on average. And the RMSE benchmarking results suggest that the predictive accuracy of our system is on par with the best performing models, if not superior, in cases such as AUD-USD. Our trading strategy is based on MACD, which is a widely used momentum indicator, measuring the difference between a shorter and longer EMA. In our case, lookahead EMA is used for better accuracy. However, MACD alone generates false positives. To solve this, we used MACD-H instead by subtracting a signal line from MACD to improve the reversal detection accuracy. The price percentage oscillator of MACD-H is also calculated and used as a signal filter. Only if it passed a preset threshold, long and short signals will be generated based on the sign of MACDH. It can be seen from the trading results that the FE-LSTM's Forex forecasting improved the result by 25.1% on average and generated an average annualized P&L of 27.7%. Here is an example of the Forex rate in black, trading signals in red and green, and P&L comparisons for USD and OK. Our portfolio allocation and rebalancing strategy is improved based on an algorithm proposed by Morgan Stanley's quant team. It is inspired by Markowitz's modern portfolio theory to maximize returns at a given risk. The dynamic allocation result is shown here. Genetic algorithm is adopted to optimize the EMA windows and oscillation threshold for MACDH. The portfolio trading result show that our optimized strategy generates a more consistent returns with a smaller standard deviation and more upside fat tails with a larger skewness and kurtosis. As a result, a Sharpe ratio of 1.1 is attained. Overall, our optimized strategy grew the portfolio by 7-folds in 9 years' time, which is 12 times better than the buy and hold strategy and 62% better than the vanilla strategy without our model forecast. In conclusion, our proposed FE-LSTM combines the strong learning capability of a deep neural network and the high interpretability of a fuzzy system. It demonstrates the state-of-the-art predictive capabilities and is highly versatile. Future projects can explore the use of different asset classes, trading strategies, and fine-tune parameters for individual Forex. Online learning can also be incorporated to further enhance its adaptability. That's all for the presentation. Thank you for your time.